In my previous video, I discussed when you might want to add agentic features to your apps. I've suggested that there's a number of options that are available to you, and you may not want to add fully autonomous agentic AI to your applications. However, as there's a range of options available, you can add something which kind of looks a bit like fully agentic AI without going to that full extent. The range basically covers, I should say, something which is deterministic and autonomous, all the way to something which is autonomous with an LLM brain that does the decision making for you, and basically kind of everything in between and roundabout. In this video, I want to do a deep dive into the agentic features of one of my apps that I've called StoryDaemon. This features within the previous video, and I mentioned that it was designed to be an agentic app from the beginning. What I didn't really cover in that video is some of the finer details as to how it works, and that's something I want to cover here. So let's talk about what StoryDaemon is in order to go a bit further. I have done a full video on StoryDaemon in the past, which is on YouTube, and there's a link to that also within the GitHub repo for the app. As I've said in many of my videos, that all of my software so far is on GitHub. It's all open source. So you can go there, you can download it, and you can try it out for yourself. What is StoryDaemon? It's an agentic novel generation system with emergent narrative. It's a Python app, and it generates long-form fiction through an autonomous agent that plans, writes, and evolves the stories organically. So right there at the very beginning, you're giving all of the power to AI in order to generate a story. So you're giving it tools, abilities, functions, and asking it to create a story, and you're not really telling it how you want that story to be. You can specify a genre and even subgenre, and you can start to specify some of the flavor of the story, but you're trying to leave most of that to the AI in order for it to make its own decisions by itself. An alternative way is to do what I did in Novel Writer, which is one of my other apps, which is where you specify everything at the beginning and then ask an LLM to follow some sort of procedural structure and then generate story based upon that structure, which is more top down, and this one's more bottom up. It's a CLI app, so it's not going to be the prettiest. It all works within the command line. It is something that you could modify in the future to have a graphical interface. It's not something that I've bothered with so far, but maybe I can add that. The real focus here was on testing out this idea of being an agentic app and being able to write story in an emergent fashion. That's where all of my time was spent in order to develop this app. So there wasn't really much thought put into a graphical interface. Maybe that's going to be a future development for me. So let's have a bit of a look at the agentic features and some of the design patterns. So whenever you give a lot of power to an LLM, you give it a lot of autonomy, you have to obviously appreciate that it is non-deterministic to some extent. There's some amount of variation within its outputs, although it's not completely random, it's not completely wild with the variation, but it has some amount of non-determinism in it, and so you have to somehow deal with that, and you have to try to guide the LLM in the right direction, or give it tools that can help it to guide itself. And that's kind of where we are here. So the tool calls we can describe as a bridge between the LLM's creative decision making, so the non-determinism, and then a deterministic story state, or world state for the story, which deals with facts. And it's hard facts such as a character's name, a character's age, the relationships that the characters might have between each other, or perhaps even the goals that the characters have within the story. So the tools allow the AI to, for example, as we've got here at the bottom, perform a semantic memory search. So it can look over the story of what has happened and basically perform a search to look for sort of similar semantic patterns, which means to search for similar meanings within the story, of what has been before. And so this is about trying to keep the facts consistent. So if you are to write a new scene at a given planet, you want some of those facts, you want those facts from before to come through and to still be there, to still be relevant. And that's why you have the search function, and it's a tool call. So when the LLM wants to write, it has to think, okay, I need to know what are the relevant facts for writing the scene. And that's what one of these tool calls does. In addition, it has tools such as creating a new character, creating a new location, or creating a new faction, as I've hinted at. And then each of these characters have relationships and they have goals. So this kind of creates the facts of the story. And then you give the LLM the power to generate a story based upon some facts, but the facts are generated through the tools, and it's not something that I design beforehand. It's not something that I specify beforehand. Lastly, it says at the bottom, it has tools for querying, so you can know who's there and who knows each other, and then what factions exist. So it's not just about generating these, but then actually knowing which of those exist. And then at the same time, as I've kind of said there, you have to have a way to update them. So there has to be a tool call that lets you update characters or updates factions, and so on and so forth. And all of this is to help with data integrity, try to prevent hallucinations as best as possible, and then to have persistent memory across potentially hundreds of scenes, which it may well be. So let's jump a little bit into the tool architecture here. So there is going to be a tool class. So all of your tools have to have a name, such as generate.character. You need to have a description, of course. There needs to be parameters, which is this JSON schema. A little bit more of that later. An execute function in order to, the LLM has to call this function and it has to execute it. And then, of course, you want to have a function that validates the arguments, such that if you pass the wrong arguments or somehow misspelled or whatever, that can be rejected, and then the LLM has to try again. A tool registry, which stores all of the tools, of course. So there could be a name and a description. And that, again, that's to help with the visibility of the tools, such that the LLM can know which tools are available within the code. So let's have a look at the tool call flow. Whenever you send a prompt to the LLM from the app, especially for the very first time, you have to give it a list of the tools that are available. So this is the tool registry. And even later, when you could be deep in the middle of the story that you're generating, you have to send prompts from the app, which is code on your machine. So whenever you're sending out a prompt to the LLM, you have to keep telling it which tools are available. Whenever you're dealing with the API, all of the management of the memory of what's true and what's real and what exists, that's all stored on your side, on your computer. That's not stored within the LLM. The LLM does the computation of the processing of the prompt and then gives you a response. But each of these API calls, which is what they are, each of these calls, so sort of questions and responses, that's all independent from each other. And that's why you have to manage everything on your side in order to bridge each of them together such that they're no longer just independent. That's not something done on the other side. If you're using something like ChatGPT, which is a web app, that manages it all for you. It manages all of the memory for you, and it gives you this coherency. So, and there has to be an app to manage it. The LLM itself doesn't manage it for you. So you're going to send this list of all the tools. Then the LLM decides which tools it should use at a given time. So it might decide, I need to create a character for the story. So it calls the tool that creates a character on your machine, and then it sends the details back to the LLM to know, here's the name of the character and here's the other features of this character. And then the LLM can then use those facts in order to write the story. And I think that's quite cool that it can do that it can call a tool in order to generate something like a character, pull that information back, and then keep going. Lastly, here is something called the plan executor, and that's where you have a plan of which tools that you want to use, and the LLM will say, okay, I want to use these tools, and here's the order that I want to use them in. So the executor will get the tool registry, it validates the arguments against the schema, so that's how it knows whether the response from the LLM is valid or not. It will look at the arguments provided by the LLM and say, okay, yep, this is good, you've given me the right arguments, therefore this is valid, and the tool can be called correctly. Then later we have actually executing the tool and then getting the results and then basically sending that back to the LLM. If there's any errors, the app is written such that any errors will just halt the execution at that particular step. It doesn't keep going. And I'll give a bit of an explanation in the next slide. So the design principles around this is that you want the tools to be deterministic rather than random or unexpected or whatever. The LLM can certainly produce a response which could be random and garbage, but you want to then basically fail in a safe way and basically reject anything that comes from the LLM that doesn't make any sense. So you do want some level of determinism in there. You don't want the LLM to have all of the power, but you do want to give it some amount of autonomy, some amount of agency, dare we say, such that it can do the right thing, which is to create a story. At the same time, there are some security concerns. So whenever an LLM has the power to, say, create a file, or to search a database, or perhaps even to delete a file, you want to make sure that there's no direct access to your system. You can do that, and it's something that we've seen being quite popular within recent weeks here, but it's not something that I want to recommend. You can do it, but I don't want to recommend that you necessarily go that route. So you want to have controlled operations. You want to provide a function, so this is a tool call essentially, that allows the LLM to create a new file as and when it needs to. And so that code, that piece of code, that function will create a file on behalf of the LLM rather than the LLM getting some greater power in order to write some commands at the command line. Because at the same time, it could put some sort of hallucination in there, and so you get a command line performing the wrong function at the command line. That could be dangerous potentially, especially if it was to remove files from your system. So if it was to delete files, then you've given it a great amount of power to write whatever it wants, and it may well write the wrong thing and delete a file or delete a database or whatever. And that's where if you give it only certain defined functions, which can only operate in particular ways, they can only function within particular ways and not in the wrong ways, not in the bad ways, then you're making everything much safer. This is a sort of like a way to create guardrails for your AI agent. The fail-fast execution at the next step basically says whenever there's an error, you stop rather than letting failures building up, i.e. cascading failures. Not much more I want to say on that. Of course, you can create the app in different ways. You can let it have a number of errors if you want. It probably depends on your use case and what you're doing, and sometimes the real world can be messy. The automatic indexing that I've mentioned at the bottom is about updating this vector database that we've mentioned, and that was to do with like the semantics search. It's not only semantic search, but it basically holds the entire story within this vector database, which you can search, and that's for the LLM to see which facts have been established before about a particular setting or a particular character, and so on. All of the story is also stored within markdown files, if I recall correctly. So you're kind of doubling up on storage, but given the amount of data that you're generating, it isn't much. So it is redundant, but it's not really a big problem, especially at this level of scale that we're dealing with. Lastly, one of the things that I want to mention, which may have been obvious from what I've been saying so far, is that the tools can chain together. But in order to do that, you have to validate the output of one tool before you can then use that as an input to a later tool. So that's what the smart chaining is. The LLM can pass a result from one tool call to the next one within the same plan. Remember, there's a plan executor that can execute different tool calls within one given plan. But you have to obviously make sure that the output from one tool doesn't mess up the next tool. And that's some of the sort of the things that are built into the code here of StoryDaemon. It's giving an example here. I don't think it's the best example, but it is an example. The LLM wants to generate a character, so first it will generate a name. And this was basically a way to let me to generate a name, put it in as the main character without generating the rest of the features of that character. It kind of made sense at the time. Part of it was that LLMs like to create their own names and then create their own facts around it if you give it the power to do so. And sometimes it doesn't create a good variation in names, so I wanted to have that control on my side. You could argue that it should just be packaged into one single tool. However, for the purpose of this presentation, I bring it up because I think it is technically two separate tool calls, and the two of them are essentially linked in sense of logically that they're linked. That when you generate a name for a character, you also want to generate the rest of it. And whenever you generate the rest of the character, you're going to use the name which is previously generated and then feed it in. So it's some amount of optionality and some amount of flexibility. So I hope this was interesting for you to do a bit of a deep dive on StoryDaemon and how it works, especially the agentic features. This is obviously where the LLM has a brain and it has some amount of decision-making power, as I'm probably made clear to you. And I want to kind of re-emphasize that this type of app can make sense if that's really what you need or what you're going for, if that's what you're designing the app for. If you've already got an app that works and you want to automate it or make it more automated than it is, you may want to use agentic patterns without necessarily giving the LLM full control over the app and all of the functions. There is actually a spectrum that you have here. You don't have to necessarily make it fully autonomous or nor fully agentic, but somewhere in between. And I think whenever we're talking about AI, we're talking about AI agents, and we're talking about all of the buzz around this, it's easy for people to get excited about AI agents without thinking, is this actually the right solution for my app, for what I'm building, for my customers, or whatever? And there's a very good chance that it isn't. So that's everything that I wanted to say in this video. Again, thanks for watching. If you can like and subscribe, that's greatly appreciated. If you have any comments that you want to ask me, then please do so in the comment area down below. And as always, my code is on GitHub. It's open source. There's a very permissive license if you want to download it and modify it. If you want to send some stars to my repos, that's also greatly appreciated. There's a link there, and there'll be links within the description of the video. Thanks for watching, and I'll see you in the next one.